Welcome to Masterclass in Heading and Direction. You might think of the North Pole as simply the top of the world. And if you're younger, maybe it's just Santa Claus's home. But it turns out, our planet has a whole host of North and South Poles. First, and most simply, there's a town in Alaska called North Pole. It's not near any of the other North Poles, but it does get snow and receives a lot of mail addressed to Santa Claus. Then there's the geographic North Pole, also known as True North. This is the spot in the Arctic Ocean where all the man-made lines of longitude converge on a map. As you might have guessed, Earth rotates once every day, so there has to be a rotational point. In layman's terms, there are two such points, and if you draw a line through them, it becomes the axis on which Earth rotates. Depending on when you're watching this video, the northern point might be on frozen ice or in the middle of the ocean. Somewhat related to the geographic North Pole is the considerably less famous instantaneous North Pole, where Earth's rotational axis meets its surface, and the celestial North Pole, where the axis pierces the night sky in an imaginary extension. The instantaneous North Pole isn't fixed. It moves in an irregular circle caused by something called the Chandler wobble, named after astronomer Seth Carlo Chandler, who discovered in 1891 that our planet wobbles as it rotates. His discovery gives rise to the North Pole of balance, which lies at the center of this wobble circle. Now let's talk about magnetic poles. The magnetic pole describes the two locations, north and south, where the planet's magnetic field is vertical. So if you're standing over the north magnetic pole with a compass, the needle would dip and try to point straight down. That's why it's also called the magnetic dip pole. Earth's magnetic field is thought to be generated by fluid motions in the liquid outer part of the Earth's core, which is mainly composed of iron. These fluid motions are driven by buoyancy forces that develop at the base of the outer core as Earth slowly cools and iron condenses onto the solid inner core below. The rotation of the Earth causes the buoyant fluid to rise in curved trajectories, which generate new magnetic fields by twisting and shearing the existing ones. But there's another magnetically based North Pole, the North Geomagnetic Pole. While the North Dip Pole lies in northern Canada, the Geomagnetic Pole is roughly off the northwest coast of Greenland. To further confuse things, the dip poles move around, sometimes even daily. The North Magnetic Pole, which used to guide compass needles, has been moving faster than expected in recent years, from Canada towards Siberia, Russia. Its annual movement has accelerated from 10 to 55 kilometers per year. And here's something to add even more confusion to the North Magnetic Pole versus the North Geomagnetic Pole. If you look at the North Pole of a bar magnet, the field lines go from the North Pole to the South Pole. But for Earth, it's exactly the opposite. That's why some people have suggested that, to avoid confusion, we should call the North Magnetic Pole the North-Seeking Pole. Now, if you're a cartographer, mariner, or surveyor, especially if you're new to the profession, there's one more north you'll need to deal with. It's called grid north. Let's look at the globe with all the beautiful longitude lines running from north to south. But when you draw the same thing on a flat piece of paper, you introduce actually a lot of errors. If you've seen Google Maps or heard about the Mercator projection, then you've probably noticed that all the longitude lines appear parallel and point straight up and down. But you know that's not true. Those lines converge at the North and South Poles. Let's check out this beautiful animation video created by Graphonaut. On a map or chart, meridians are always straight up, and there's no singular point on the chart telling you which direction is north. That's what we call grid north. If you're a cartographer, mariner, or surveyor, then you must know there's a difference in angle between grid north and true north. We call this difference convergence. More on convergence in later videos. In our next videos, we will learn about what is vessel's heading, how gyrocompass shows true north, magnetic declination, and how to calibrate gyrocompass. Keep watching next video.